Welcome to calculus. Whatever confidence you have will be tested. But don't worry, Stevenson has tools to help you. On this episode, Stevenson will demonstrate
Do you remember what it means to average? What it means to find the average? Well, hopefully you remember when you average something, you're just adding up all of the quantities or numbers and dividing by how many they are. Well, we can average functions. We can find the average value of a function, and we can do that with our definite integrals. Remember, a definite integral represents the output of some quantity. So when you're averaging it, you're basically saying, what's the average output? Okay. So let's look at some work of where this formula comes from. So what we're going to do here, and what we say is, what if we take a large sample of n numbers, right? So we want to take a lot of numbers and we want to average them. Okay, but we're going to take those numbers on a closed interval from A to B. So if we're going to average something, we're going to figure out what are all those outputs, right? What are all those numbers divided by how many there are. Okay. So if you take this expression, you can rewrite it. See that sum? You can rewrite it using sigma. Remember, sigma means to add up. And then you have 1 over n out front. Now the 1 over n comes from the fact that you have 1 divided by n times a sum. Okay. Then the book jumps into here, and it's like, oh my goodness, where did this come from? This delta x over b minus a. Well, let me show you. And it starts with up here. What does delta x represent? Delta x represents, right? Remember, that's the length of each of the subintervals, correct? And you do b minus a divided by n. Okay. Well, let's do a little manipulation with it. If I multiply by n, I get that expression. If I divide by delta x, I now get that expression. And if I do the reciprocal on both sides, I now get that expression. Notice, this tells me I can now take 1 over n, and I can substitute in delta x over b minus a. So that is where delta x over b minus a comes from. Now in the next step, you can see it just says 1 over b minus a. Well, the delta x gets moved inside with the summation. And now you're left with 1 over b minus a. So if you think about, what does 1 over b minus a represent? Well, b minus a is the difference of your interval, right? Okay. And you're just doing the reciprocal of that. So that's what 1 over b minus a means. Well, what does that part in green mean? That should look familiar to you. That's going to be the sum of all the areas, right? That's our definite integral. So that's where this formula comes from. So whenever you're asked for the average output of some rate function, or what's the mean output of something, then you're going to do this formula. So you're going to do the integral the way you normally would, but you're going to multiply it by a 1 over b minus a coefficient. Do you remember the mean value theorem for derivatives? Right? It tells you if a function is continuous on a closed interval and differentiable on an open interval, then there's at least some point where the instantaneous range will equal the average rate of change. Well, there's a mean value theorem for definite integrals, and it uses average rate of change. So essentially what it says is that if your function is continuous on a closed interval, then there will always be at least one number, one input, that will equal that average value. Okay, so what this says is if your function is continuous on a closed interval, then f of c, where c is some point in your closed interval, this will be true. So in other words, the function evaluated at that number, whatever it is, will give you whatever that average value is.